Alright, we're almost done with the section. We're working on this problem now. Note there's a typo in Folland's textbook. Actually, there's quite a few typos, but one of them is right here in this exercise. We need to have a subscript of e there. Okay, so in this problem, the first thing I'm going to do is first I claim, well actually, we're just going to start off by saying I claim that we can use P equal to the set where f is positive and be the set where f is strictly negative, nu plus be where, or nu plus equal f plus d mu, not mu, nu minus equal f minus d mu, and total variation of nu equals norm f d mu. Hopefully my computer won't freeze this time. Without loss of generality, assume the integral of f minus d mu is less than infinity. Why can we do this? Well, f is an extended mu integrable function, which means that we can integrate f anywhere, and we might get positive infinity, or we might get negative infinity, but it's not the case that we can get positive infinity in one region and negative infinity in another region. So basically we can assume that either the integral of f minus d mu is finite, or the integral of f plus d mu is finite. And we're just going to take the minus case. Alright, so let's move on to claiming that we have a Hahn decomposition. So P union n is equal to our entire space X, because P is where f is greater than or equal to 0, and n is where f is less than 0. And f is always going to be some value, so it's either going to be less than 0 or greater than or equal to 0. So the union of those two regions is all of x. And P intersect n is equal to the empty set, because f can't be both negative and strictly not negative. Okay, so also we have if E is a measurable subset of P, then what is nu of E intersect P? This is equal to the integral over E intersect P of f d mu by assumption, but since we're integrating over P, this is exactly where f is equal to f plus. So we have this, and this is greater than or equal to 0. And if E is a subset of n, of course measurable, then nu of E intersect n, similar story, E intersect n of f d mu. Now this is equal to E intersect n f minus d mu, which is less than or equal to 0. And this is because f minus, let's see here, no, this is actually, because f is equal to f plus minus f minus, so this is actually going to be a negative here. And so we're integrating a positive function with respect to a positive measure, so we get a positive value, and we're taking the minus of that, and so that's going to be less than or equal to 0. So what that says is that P is a positive set and n is a negative set. Hence, P union n is a Hahn decomposition of x with respect to nu. Alright, let's move on. Next, for all subsets E, let's just write e belonging to our measurable subspace. So here we have nu plus of e. What is this? This is just the integral of e intersect p of f d mu. And what is that? Here, of course, we can write this as e intersect p of f plus d mu. And because we're integrating over p, this is just the integral of e of f plus d mu, because when we integrate over e intersect n, f plus is equal to 0 there identically. And so this tells us that nu plus is equal to f plus d mu. Likewise, for all e in our measurables, or in our sigma algebra M, nu minus of e is equal to the integral over e intersect n of f d mu. Right. Alright, so now that I've taken a little bit of time to regather my bearings, what we want to do is we want to look at nu minus of e. But now we go back to the definition, and what does this mean? Remember that nu equals nu plus minus nu minus. And so this is just nu plus minus nu. Well, nu plus of e minus nu of e. Okay, and so what is that? That is, we already know this is the integral over e of f plus d mu. I'm going to subtract the integral over e of f d mu. And so what's going to happen here is that this is equal to the integral over e intersect p of f d mu minus the integral over all of e of f d mu. And so this is actually equal to the integral over e intersect n of minus f d mu. Because when we look at e intersect p, these two cancel out. But when we look at e intersect n, this is 0 and this is still here. So anyways, we have this. And so what is this? This is just equal to the integral over the integral over e intersect n of negative f d mu is just going to be equal to the integral over e of f minus d mu. Alright? So, what does that mean? That means exactly that nu minus is equal to f minus d mu. And then further, not further nor, but furthermore, for all e in M, total variation of e equals nu plus e plus nu minus e. That's equal to the integral over e of f plus d mu plus the integral over e of f minus d mu. That's equal to the integral over e of, what is this, f plus f minus d mu. And that's literally just the integral over e of the norm of f d mu. And that basically confirms everything that we wanted. We have this is a Hahn decomposition, we've got this thingy, we've got this thingy, and we got this. So nu equals f d mu. So we've got this thingy, and we are done.